So the next lesson we're going to be doing is we're going to be solving linear trig equations. So basically, it doesn't involve quadratics. It involves linear expressions. So for example, a linear expression would be 2x minus 1 is equal to 0. That's an example of a linear equation. Or in this case, y is equal to 2x minus 1. That is a linear equation. So let me just present that screen because I'm not presenting it right now. Let's see. Okay. So like I said, we're going to be looking at solving linear trig equations. So an example of a linear trig equation, or an example of a linear equation in general, would be y is equal to 2x minus 1. And obviously, when it comes to linear trig, when it comes to linear equations, we are always solving for the roots. So to solve for the root, we just set y equal to 0, which gives us 2x minus 1 is equal to 0. And when we isolate for x, we get x is equal to 1 over 2. So this is where you're going to have to remember your special triangle, your special triangles, what power over 4 gives you, what power over 3 gives you, what power over 6 gives you. And you're going to have to remember the values that they give back with sine, cosine, and tan. So some strategies for solving trig equations. So because of their periodic nature, trig equations have an infinite number of solutions. When we solve for a specific trig equation, we usually want solutions in a specified interval. So the questions will usually say, find the solutions to this linear trig equation within, let's just say, power over 2 and 2 pi. Okay, so you usually get intervals or restrictions that involve that sort of matter. And to solve a linear trig equation, we use the unit circle or the special triangles, a calculator, a sketch of the graph, or the cast rule. So some things we want to watch for. So is the domain specified? If not, remember that the graph of sine and cosine are continuous, and therefore there are an infinite number of solutions will exist if we don't have a specified domain. So as you can see in the example 1, this is our specified domain. We want from negative pi to 2 pi. So this is our specified domain. So we want to use identities in all of our relationships to express the equation in terms of a single trig function. We want to apply the double angle formulas to match the arguments and then solve for the variable within the newly specified domain. So for example, in this case, we have x is less than or equal to 2 pi, but greater than or equal to negative pi. If we have the double angle formula 2x, we multiply both sides by 2. So which means our domain changes when we have a double angle formula. So we would have 2x is less than or equal to 4 pi, or greater than or equal to negative 2 pi. And that also involves if we have, let's just say if our example was x over 2, we're just dividing both sides by 2, so we're left with pi and negative pi over 2. So just keep in mind that the double angle formula just changes the domain of the function because of that 2x. So if the domain is in radians, then your answer should be in radians. If the domain is in degrees, then your answer should be in degrees. So when you're doing your homework, the textbook has a, I don't know why, they always give, so if the domain is in radians, they sometimes might give the answer in degrees and vice versa. So in this case, just try to keep everything consistent, okay? So now let's move on to example 1. So in example 1, we have solve for x in the interval of negative pi and 2 pi for the equation cos of x is equal to negative 1 over root 2. So we have cos of x is equal to negative 1 over root 2 or negative root 2 over 2. So before we sketch it out, what angle does cos of x give us root 2 over 2? So x is equal to pi over 4. Okay? So normally, if cosine is root 2 over 2, our angle is pi over 4. But because our expression is cos of x is equal to negative root 2 over 2, in what quadrant is cosine negative? So in quadrant 2 and 3. So cos x is negative in quadrant 2 and quadrant 3. So which means it can be in this place over here in quadrant 2 and in quadrant 3. So remember, this is 2 pi, this is pi over 2, this is pi, and this is 3 pi over 2. So remember, our restrictions is from negative pi and 2 pi. So since root 2 over 2 is represented by pi over 4, how am I breaking up each quadrant? So we're breaking up each quadrant into 45-degree intervals. So we have 0, 45, 90, 135, 180, so forth. So now just visually, what is our first angle or radian measure where cos x is equal to negative root 2 over 2? (135), but in radian measure, what does that equal? (3 pi over 4). That's our first radian measure. What would our second radian measure be? So we have our terminal arm in quadrant 2, but we also have a terminal arm in quadrant 3. So our next possible radian measure is 5 pi over 4. And we are missing one more answer here. So look at the restrictions. It says from negative pi to 2 pi. Let's see if you guys can figure this one out. So when we talk about a negative angle, which way are we going? Clockwise or counterclockwise? So we're going clockwise, which means Adam's answer is the correct one. So our last angle is negative 3 pi over 4. So this is positive 3 pi over 4. This is positive 5 pi over 4. And then if we go negative, so clockwise, this is negative 3 pi over 4. So those are the three values of x that give us cos of x is equal to negative 1 over root 2, given its domain from negative pi to 2 pi. So x is equal to 3 pi over 4, 5 pi over 4, and negative 3 pi over 4. So is everyone good so far? All right, perfect. So now we're going to move on to example 2. And as you can see from our domain, this is in degrees and not radians. So our answer is going to be in degrees. Okay, Juliana, what part did I lose you on?
Like the whole thing. I just don't understand like why we did what we did to get there.
Okay. So for our example, it gives us our domain. So our interval for this function is from negative pi to positive 2 pi. And our equation is cos of x is equal to negative 1 over root 2. Or because we don't want the roots at the bottom, we get negative root 2 over 2. So if we use the cast rule, the quadrants and where cosine is negative is in quadrant 2 and in quadrant 3. Okay, so cosine is negative in quadrant 2 and quadrant 3. And so which means when cos of x is positive root 2 over 2, it is with the angle of pi over 4. So in this case, it is 45 degrees. And we just use our special triangles to figure that out. So let's see, this is pi over 4. So we have 1, 1, and root 2. So if we do cos of pi over 4, it gives us 1 over root 2. So the reason why it's pi over 4 is because it corresponds with the special triangle of pi over 4. As you can see, I drew it up here. So we have root 2 as our hypotenuse, 1 as our adjacent or x value, and 1 as our y value. Which means cos of pi over 4 is 1 over root 2 or root 2 over 2. So because cos of x is negative 1 over root 2, the terminal arms lie in quadrant 2 and quadrant 3. So when we split up our quadrants, they're going to be split up into 45-degree intervals like we learned last unit. And all we're doing to get each answer is counting the number of sections we passed. So from 0, we pass 1, 2, 3. So our first angle where cos x is equal to -1 over root 2 is at 3 pi over 4. And then our next terminal arm is in quadrant 3. So we continue. This is 4 and 5. So our next angle is 5 pi over 4. And because we have that negative pi, we have to figure out an angle that is clockwise from the origin of 0. And in this case, it was -3 pi over 4. So we have 3 sections of 45 to get us to that quadrant 3 angle. So hopefully that cleared it a bit up for you. Okay, perfect. So our next example, we want to solve 3 times 10x plus 1 is equal to 2, where x is greater than 0 degrees and less than 360 degrees. We want the answer to 1 decimal place. So what we want to do first is treat this like a regular algebraic expression. Okay? So we have 3 times 10 of x plus 1 is equal to 2. So what would our first step be into solving for this algebraic expression? You don't necessarily have to factor in the 3. So what can you do right away? So remember, with these linear trig equations, we're always solving for x. So we want to leave 10x by itself. So what we're going to do first is divide both sides by 3. So we get 10x plus 1 is equal to 2 over 3. And then the next step is we're going to move the positive 1 over. So we get 10x is equal to 2 over 3 minus 1. And when we simplify that, we get 10x is equal to -1 over 3. But because there is no special angle that gives us a ratio of -1 over 3, what do you think we would have to do? What was that? How did they teach you how to figure out degrees in grade 10 and 11? So we're going to take the inverse of 10. So we get x is equal to 10 inverse of -1 over 3. So because 10 is negative, in what 2 quadrants is 10 negative in? It's a negative in quadrant 2 and quadrant 4. So if we take 10 inverse of -1 over 3, what is the angle that we get? So x is equal to -18.4 degrees. So let's draw this out on our Cartesian plane. So we have x is equal to, so this is our angle x. This is -18.4 because we are going clockwise. But this hand also extends into quadrant 2. However, we can't be going clockwise because our restrictions is from 0 to 360. So we want to find the angle from the origin to this terminal arm and the angle from the origin all the way to the terminal arm in quadrant 4. So what two angles does this give us? Oh, so the calculator should be on degrees, not radians anymore, if you want to change stuff into degrees. Yep, 161 and 341.6. So for angle in quadrant 2, we're just going to take x is equal to 180 minus 18.4, and that gives us 161.6. 161.6. And in quadrant 4, all we're doing is 360 minus 18.4, which is equal to 341.6 degrees. So when you're solving problems that have degrees in it, make sure your calculator is in degrees and not radians. All right, let's move on to our next example. So the example 3 is pretty straightforward. So we want to figure out what quadrants contain the solutions to the equation 5 times cos x is equal to -1/2. So we have 5 cos x is equal to -1/2. How do we leave cos x by itself? So we're going to divide both sides by 5. So we got cos x is equal to -1 divided by 5. Cos x is equal to -1/10. So because cos is negative, therefore what quadrants is cos negative in? 2 and 3. So therefore, the solution is contained in quadrant 2 and quadrant 3. So our next example, we want to determine the solutions for sine 3x is equal to √3/2. So because this ratio is positive, in what quadrant is sine positive? So it's positive in quadrant 1 and quadrant 2. And if you take the regular sine x is equal to root 3 over 2, what radian measure gives us an angle, gives us the ratio of root 3 over 2 in our special triangles? So at what angle does sine x give us root 3 over 2? So at pi over 3. So if we were to draw it out, so this is at pi over 3. And if it's in quadrant 2, it is at 2 pi over 3. And like I said, this is in quadrant 1 and quadrant 2. So our interval is from x is less than or equal to 2 pi and less than and greater than or equal to 0. But because of the fact that sine 3x is there, what happens to our domain? You multiply both sides by 3. So you get 3x is less than or equal to 6 pi, but greater than or equal to 0. So when we have sine 3x is equal to root 3 over 2, we have our x values are equal to pi over 3, 2 pi over 3. So sine 3x is equal to root 3 over 2, which means 3x is equal to pi over 3 and 2 pi over 3. But if we just want to get it down to x, what do we have to do? So we're going to divide by 3, which means our x values are x over 9 or pi over 9 and 2 pi over 9. All right, this is going to be our second last example, and then I'll do one more, and then we will take a little bit of a break. So we want to solve for cos of x over sine 2x is equal to 5 over 7 for x is greater than or equal to 0 and less than or equal to 2 pi. We want the answer in 2 decimal places. So because it's in radians, we are going to use radians. So we have cos of x over sine 2x. So because our numerator and denominator don't have a similar expression, What type of formula do we have in our denominator? So we have our double angle formula. So we have cos of x divided by 2 sine x cos x is equal to 5/7. So now this makes it much more easier. So what two things can cancel out from the left side? So the cos x cancel each other out. Which means we're left with 1/2 sine x is equal to 5/7. All we're going to do is cross multiply. So we get 7 is equal to 10 sine x. And because we want sine x by itself, we're going to divide both sides by 10. And now because it's in radians, we have to change our calculator into degrees. So we're going to take the inverse of sine of 7/10. And that gives us approximately a radian measure of 0.78. So this measurement is in quadrant 1. And because sine is a positive ratio, sine is positive in which other quadrant? Okay, so we have a radian measure here of 0.78 radians. And we need to figure out this other measurement over here. So we have x is equal to 0.78, or x is approximately what else? So you know when it's in radians because of the domain is in radians. So when it's in the expression of pi over 2 or 2 pi or 3 pi over 2, that signifies that it's in radians. If it's in degrees, like the example we did like 2 questions ago, where it was between 0 and 360 degrees, then you use degrees. So because it's in that formula or in that format, that is in radians. So to figure out in quadrant 2, we're just taking pi minus our angle x. So we get pi minus 0.78, which gives us 2.36. So you guys starting to kind of get it now? Like a little bit? Okay, so let's just do the last example and then you guys will get a break. So this is a word problem. So tonight is a full moon. So tonight a full moon is out. The percentage of the moon that is visible, V, according to the number of days from now. D is modeled by the equation. V of D is equal to 0.5 cos of 2 pi D over 29.5 plus 0.5. So the questions we have are, how many days is there until a new moon? Including tonight, how many full moons will there be in the next 100 days? And how many days will it be until there are 5 full moons, including tonight's? So for A, so when V is equal to 0, that means there is a new moon. And when V is equal to 1, that means there is a full moon. So we want to figure out how many days until there is a new moon. So we have to set V of D equal to 0. So you get 0 is equal to 0.5 cos of 2 pi D over 29.5 plus 0.5. So we need a let statement because of the fact that it's going to be very difficult to simplify 2 pi D over 29.5. So we'll say let theta equal to 2 pi D over 29.5. So we're left with 0 is equal to 0.5 cos theta plus 0.5. So what is our first step to isolating for cos theta? So we're going to move the 0.5 over, so it becomes negative 0.5 is equal to 0.5 cos theta. And then all we're doing is dividing both sides by 0.5. So we got cos of theta is equal to negative 1. So at what angle or at what theta value is cosine negative 1? So pi. So theta is equal to pi or 2 pi or 5 pi and so on. So therefore we can say that theta is equal to pi. And because we have our let statement, now we can figure out the number of days. So remember we said D is days. So we have theta is equal to pi, 2 pi D over 29.5 is equal to pi. So we're just going to cross multiply. So we get 2 pi D is equal to 29.5 pi. And what is the last step we need to do to solve for D? So we're going to divide both sides by 2 pi, which means the pi's cancel out. So D is equal to 29.5 divided by 2, and D is equal to 14.75. Therefore, it is 14.75 days until the new moon. So the reason,
Sir,
yes.
I'm kind of confused about what'd you do with the whole theta thing? Like, how'd you get theta equals pi?
So with any problem, you can always have a let statement. So in this case, we let the bracket be our theta. So we let theta equal to 2 pi times z over 29.5. Okay. So that means our expression was simply just v of d is equal to 0.5 times cos theta plus 0.5. So because when v equals 0, that means a new moon, we set v of d equal to 0, which left us with 0 is equal to 0.5 times cos of theta plus 0.5. And then all we did was isolate for cos theta. And then we got, when we simplified everything, we got cos theta is equal to -1. Okay? Now to figure out our theta value, we needed to ask ourselves at what theta value does cosine give us -1? And that was a value of pi. So cos is -1 when the angle is 180, or in radian measure, it's pi. So we had theta is equal to pi, which we had above over here. But because we had our let statement, we just subbed in 2 pi times d over 29.5 in for our theta value over here.
Oh, okay. Thanks, sir.
No worries. So we're going to move on to question B. So B is asking us, including tonight, how many full moons will there be in the next 100 days? So we said when V is equal to 1, that means there's a full moon. So we're going to use the same thing. Let theta equal to 2 pi d over 29.5. So we get 1 is equal to 0.5 cos theta plus 0.5. And we're going to do the same thing as usual. Move the 0.5 over. So we get 1 minus 0.5 is equal to 0.5 cos theta. You get 0.5 is equal to 0.5 cos theta. Divide both sides by 0.5. And we get 1 is equal to cos of theta. So at what angle does cosine give us positive 1? Or what other angle does it give us positive 1? So theta can equal 0 or 2 pi. So it doesn't matter which one we use. So we'll take theta is equal to 0. So we have 2 pi d is equal to 0 over 29.5. Obviously, when we cross multiply, we get 2 pi d is equal to 0. Divide both sides by 2 pi. You get d is equal to 0. So that means from the very start, there is a full moon. So obviously, there's going to be more than one full moon. So we need to use theta is equal to 2 pi to figure out in how many days will there always be a full moon. So we get theta is equal to 2 pi So 2 pi d over 29.5 is equal to 2 pi. We're going to cross multiply. Divide both sides by 2 pi. And we get d is equal to 29.5. So every 29.5 days, there's going to be a full moon. So we have a full moon on the first day. We have a full moon on day 29 and a half. Then we have a full moon on day 59. Then we have another full moon on day, what is that? 29. On 88.5. So how many full moons will there be in 100 days? 4. There will be 4 full moons in the next 100 days. And then last but not least, we have our C. So it's asking how many days will it be until there are 5 full moons, including tonight. So based off the information from question B, how many days will it take until there are 5 full moons? So all you're doing is taking 88.5 and adding 29.5. That will give us 118 days for there to be 5 full moons. Okay, so that was lesson 6.5. So that involved the linear relations of trig ratios.